In an eBGP-based IP fabric, each device is often configured as a unique autonomous system, or AS. The private AS number range is available to be used within an IP fabric. Additionally, 32-bit AS numbers can be used to increase the number of AS values available. The use of unique AS numbers on each node enables the built-in BGP path selection and loop prevention mechanisms to be implemented. With eBGP peering, BGP peers connect to the IP address of physically connected devices, and therefore there is no need for an underlying interior gateway protocol, or IGP. Every leaf node peers to each spine node. Since BGP peering sessions mirror the physical topology, there is no BGP peering session between leaf nodes. Leaf nodes receive routing information through the peering session to the spine nodes. By default, if a route to the same destination is received from two different BGP peers which belong to different autonomous systems, or ASS, only one of the routes will be selected as active in the routing table. To take advantage of the redundant paths within a BGP-based IP fabric, the multipath multiple AS parameter can be configured. This parameter enables the device to install all paths to a remote destination in the routing table, also known as Routing Information Base, or RIB. To export all potential paths in the routing table to the forwarding table, a load balancing policy must be configured and applied to the forwarding table as well.
The example illustrates a route to network 10.1/16 advertised by the given leaf nodes. The given spine nodes receive the route from two separate peer ASs. The default behavior of the spine nodes is to choose one available next hop for network 10.1/16 and install that next hop as the active next hop in the routing table. The selected next hop in the routing table is then exported to the forwarding table. To enable both advertised next hops to be installed in the AS65001 and AS65002 devices, the multipath multiple AS parameters are configured on the BGP peering sessions. This enables all potential next hops for network 10.1/16 to be installed in the routing table. Leaf nodes are connected to multiple spine nodes. To load share traffic among all spine nodes, the same parameters must be configured on leaf nodes as on the spine nodes to enable multiple paths to be installed in the routing and forwarding tables.
An eBGP fabric does not require that each device be configured with a unique AS number. In the example shown, all the spine nodes are assigned the same AS number, and all the leaf nodes are assigned the same AS number. This is a valid An eBGP fabric does not require that each device be configured with a unique AS number. In the example shown, all the spine nodes are assigned the same AS number, and all the leaf nodes are assigned the same AS number. This is a valid eBGP fabric configuration, but introduces some additional things to take into account. One of the built-in functions of the BGP protocol is loop prevention. The BGP protocol prevents loops by tracking the AS numbers through which a route has been advertised and drops a route that is received if that route has the local AS number in the AS path property of the route. In the example, all leaf nodes are configured with AS .65001. The leaf nodes connected to network 10 .1/16 advertise the 10.1/16 network to the spine nodes. When the route is advertised to AS65000, the leaf nodes add their local AS number to the front of the AS path field of the advertised route. When the spine nodes in AS65000 receive the route, the AS path parameter is analyzed, and no loop is detected, as AS65000 is not in the AS path list. Both spines advertise the 10.1/16 network to connected BGP peers and prepend the locally configured spine AS to the AS path. When the route arrives on another leaf configured with AS65001 and the advertised peer AS statement is configured, the AS path is examined, and the receiving router determines that the route has been advertised in a loop, since its locally configured AS number is already present in the AS path parameter. To change this behavior, BGP can be configured with the AS override parameter or with the loops parameter. The AS override parameter overwrites values in the AS path field prior to advertising the route to a BGP peer. Normally, the AS of the device that is overriding the AS path parameter is used in place of the specified value. In the example, the AS65000 router would replace all instances of AS65001 with AS65000 prior to advertising the route to its peers, and therefore the leaf device in AS65001 would not discover its locally configured AS number in the AS path of the received route. Alternatively, the receiving device can be configured to permit the presence of the locally configured AS number a specified number of times. In the example, the parameter loops2 is used to permit the route to contain the locally configured AS number up to twice before a route is considered a loop. When enabling an IP fabric, you should follow some best practices. Remember, two of the main goals of an IP fabric design are to provide a non-blocking architecture that also provides predictable load balancing behavior. Some of the best practices that should be followed are: all spine nodes should be the same type of router. They should be the same model, and they should also have the same line cards installed. This helps the fabric to have a predictable load balancing behavior. All leaf nodes should be the same type of router. Leaf nodes do not have to be the same router as the spine nodes. Each leaf node should be the same model, and they should also have the same line cards installed. Every leaf node should have an uplink to every spine node. All uplinks from leaf node to spine node should be of the same speed. This helps the fabric to have predictable load balancing behavior and also helps with the non-blocking nature of the fabric. For example, assume that a leaf has one 40 gigabit Ethernet uplink and one 10 gigabit Ethernet uplink to the spine. When using an IGP such as OSPF for loopback interface advertisement and calculating the shortest path to the destination, the bandwidth of the links are taken into account. Mostly, OSPF chooses the 40 gigabit Ethernet interface during its shortest path first or SPF calculation. It uses the interface for forwarding towards remote next hops, which essentially locks the 10 gigabit Ethernet interface from ever being used. In the EBGP scenario, the bandwidth will not be considered, so the traffic will be equally load shared over the two different speed interfaces. Imagine attempting to distribute a 60 gigabits per